303 Group 60, and we will be investigating the tears of wine, a variation of the Marangoni effect. And we have a few videos to explain our project.
Most people who drink wine have seen the weird drops that form around the side of the glass. Traditionally, they're called tears or legs of wine. But what most people don't realize is that if you watch patiently, these drops are actually moving around. They're falling, forming, and refalling over and over and over again. So the obvious question is, what the hell is going on here?
Okay, our hypothesis is that the water moves upwards due to the Marangoni effect and also capillary action. The equation for the Marangoni effect is seen on our slide. First, you see the differential to surface tension over the change in temperature. There's a change in surface tension because when a little part of the wine goes up on its own, the ethanol actually evaporates because it has a lower flash point than water. So the water is left behind, and water has a higher surface tension than ethanol. So the little bit of water that has the where the ethanol evaporated has a higher surface tension than the wine. That means that the wine will move up towards the higher surface tension area, and then gravity will pull it back down. The change in temperature is due to cooling that occurs when evaporation occurs.
For the capillary action, with a temperature difference, an average rise of the liquid going up the glass could be 1.3 millimeters with a 4 centimeter radius and a 70-degree angle. Capillary action is the ability of a liquid to flow in narrow spaces without the assistance of or even in opposition to external forces like gravity. It occurs because of intermolecular forces between the liquid and surrounding solid surfaces. If the diameter of the tube is sufficiently small, then the combination of surface tension and adhesive forces between the liquid and container will act to propel the liquid up.
Okay, what can we conclude from this investigation? Well, one, the Marangoni effect occurs because the ethanol evaporates at a lower temperature than water. The second point is that water rises due to a gradient in the surface tension and temperature and due to capillary action.
This picture is a picture of a regular glass of wine and what it would look like over a period of time. Now we're going to show two more diagrams that will further illustrate the process of tears of wine in more detail.
Due to the difference in adhesive properties between ethanol and water, a surface tension gradient is created, which provides the driving force for the tears of wine effect, as we have talked about.